Welcome. My name is Whitney Lee. I'm a CNCF ambassador, and I'm here with Friedrich. Friedrich, will you tell us about yourself, please?
Hi, my name is Friedrich Gonzalez. I'm a software engineer, 20 years of experience. The last 6 years, I've been working with Cortex at the Observability team at Adobe.
Amazing. So Friedrich and I just had an almost 2-hour-long conversation about Cortex. I went from zero to knowing all of this information, but perhaps you don't want to watch that long recording. Although if you do, we'll have a link to it in the show notes. But here's a recap for you. Everything you need to know about Cortex in maybe, probably less than 20 minutes. We'll see. Before we talk about Cortex specifically, I would love to give some context by talking about Prometheus. So what's Prometheus?
Yeah, so it's a tool that is used to collect and store metrics, right? And we are able to query metrics and create alerts with it.
And to be clear, Prometheus is a great tool and it's ubiquitous, but there are some shortcomings because Prometheus was designed to run on a single machine. So what are some of those shortcomings of Prometheus?
Yeah, so like you said, right, it's designed to run in a single machine. Typically, when you scale horizontally, you need more than like one machine, and then eventually you start having more and more Prometheus scraping different instances and then scraping different applications, and that can get to 100, 1,000 Prometheus. That can become difficult to maintain. It's a problem, right? It's
a problem because different teams all sharing all these Prometheuses, one might take up too much space. It's a problem because it's hard to manage centrally. It's a problem because when you query that data, it could be really slow if you're querying a huge amount of data, or with Prometheus, it could be hard to know even where that data is. So there are some frustrations with running Prometheus in a distributed architecture and at scale, and that's where Cortex comes in to help save the day. So so what is Cortex?
Cortex is a multi-tenant, highly available, horizontally scalable, long-term storage solution for metrics. It's based on Prometheus.
So that's great. There's a lot to unpack there, and we will touch on what all of those things mean. Multi-tenant, highly available, highly scalable, long-term storage. Before we dig into that, one more little piece of context, and let's say what kind of data we're talking about when we say metrics. What are metrics?
Yeah, well, metrics are important values that we need to know in specific times, right? Think of it of things that you need to know, right? The known unknowns. And the nice things about metrics is they're cost effective when used properly, of course.
Excellent. So before digging into all the specifics of Cortex, one thing that we did was to talk about the architecture of Cortex overall. And so let's start by talking about this distributor component. What's a distributor?
Well, a distributor is the component that receives in the ingestion, right? The metrics, right? We when you have a Cortex, it's supposed to receive the metrics. Cortex is an API, and that distributor is scalable, and it's also stateless.
So it can receive metrics from 3 different sources, from either Prometheus, from OpenTelemetry Collector, or from an application that's instrumented with OpenTelemetry. And it gets data, and then what does it do with that data?
Well, the distributor, it uses the hash ring to send the data over to the ingestors, right?
Since you said hash ring, what is a hash ring?
Yeah, the hash ring is an algorithm that allows the distributor decide where to send the data to, right? It's based on the metric name and the metric label that hashes those values, and that's how it makes the decision where to send. So it's a very fast decision. It doesn't have to store anything. It always resolves to the same ingester. So that's how distributors are able to find the ingestors to send the data out.
So the distributor gets the data. Then there are 3 ingestors running, and the distributor sends the data to all 3 ingestors. So now it is in triplicate. What happens next?
Well, what happens next is the ingester stores the data locally. Ingestors works a bit like Prometheus, right? Stores the data locally and periodically sends the data over to S3 bucket.
So it receives the data, it stores it locally, periodically sends it to an S3 bucket. You told me about every 2 hours.
Yes.
And then,
yes.
Yeah. And then when it sends it to the S3 bucket, it wiped from the ingester immediately?
No, it's stored for a period of time. It might be like 12 hours that you decide to have the data in the ingesters. The reason for that is because the data that you can query from the ingesters is really fast, right? It's data that is very fresh as compared when you're querying that data directly from S3 bucket.
So ingesters keep data for maybe about 12 hours, configurable amount of time, but usually 12 hours, and be able to query it quickly. But it's also after about 2 hours, it's sent to object storage. What's the advantage of sending it to object storage?
It's about storing data for long periods of time, right? Like you're saying, ingesters are you're running in a single machine. Single machines has limits, right? Limits in disk and space. Object storage is cloud providers, they typically have all the space available possible. And they're also cheap to store data.
To save money, and makes a lot of sense. So our distributor sees data, gets 3 copies to 3 ingesters. Now 3 ingestors, all 3 send their data to object storage. So now it's in here 3 times. So what component takes care of that?
The compactor comes in, right? The compactor is another component that is always watching the object storage and is finding those duplicated data and deduplicating the data. It does that to simplify to be able to query the data faster, right? It also compresses the data to long, like for example, 24-hour blocks and things like that. So it's certain amount of deduplication that does the compactor that does to save money, of course.
Excellent. So now we have our data in the short term stored across these 3 ingesters, and the longer term in object storage. How do we access our data?
That's another component and another set of components. Here we simplified, we just mentioned the querier. And the querier is a component that's able to query ingesters when this very fresh data lasts 12 hours, like we said, and when all the data is able to query the S3 bucket.
So from a user experience, you just know you're querying data. And it's the querier that it does the job of knowing where that data is. So it knows based on age. It sounds like if it's older than this amount of time, I'm going to look in object storage. If it's younger, I'm going to look on the ingesters. And also you talked about that hashing ring. So the hashing ring is how it's able to know which ingester it's on, for example, or where exactly it is by without having any state. So both the distributor and the querier are stateless and therefore very scalable. What's the user experience? Is there like a UI, or how do I query the data?
The Cortex doesn't, and contrary to Prometheus, doesn't have a UI. So you can query typically with Grafana, right? That's what most people do.
Cool. And one more thing about the querier, it has a caching layer. Will you talk about the caching layer for the querier too?
Yeah, there's a number of caches that are in Cortex in the query layer. Actually, 4 types of caches. They're all used for making things faster in terms of queries. So we know data that can go to S3 bucket can take more time to re-query. And when you have a cache locally in this component, the cache, that's when you're able to respond faster.
So now we got into a little more information about high availability in Cortex. What did you say about geo-replication?
Yeah, so we talked about high availability, right? How was one of the shortcomings of Prometheus. So in the case of Cortex, one can lose an ingester, right? And it's not a problem. You don't have to lose your sleep because of that. It's all embedded in the algorithm. That's why it's highly available.
And then you also said it can be configured to tolerate losing an availability zone too.
Yeah, so that's the other feature of Cortex, is that there's also the capacity to set up different ingesters in different availability zones. So you're able to lose one entire availability zone in case of a cloud provider, and then your data doesn't have any problems, right? Because data is replicated 3 times.
And then another cool thing that Cortex does is multi-tenancy. Will you explain how that works?
Typically what happens in Cortex is you have a proxy that receives the request before the distributor. That proxy converts to a header that header passes along all the components inside Cortex, right? Query, ingester, distributor, all the components. And that allows to do some nice things.
So identity is attached to the data. The identity is used, however, whatever you're using for your identity in your system anyway. You can use that same mechanism to attach identity to your metrics data. And then that identity stays with the data as it moves through the system. And because of that, Cortex can do some cool things. You talked about implementing limits. Do you want to get more information about that?
Yeah, so there are multiple types of limits, and the most interesting ones are the ingestion limits, right? So you can configure per tenant a different ingestion, so they able to. So when the data surpasses that limit, data is rejected. And why is that? Because we want to protect the integrity of Cortex. We talked about also high availability is also about not ooming, and you can do all of that, setting all those limits. Also because of the query limits, right? So we know queries can be heavy on Prometheus. In the case of Cortex, doesn't happen because you can set up those limits per tenant and you don't have the same problems.
And also different teams can't see each other's metrics too, which I think is pretty cool. Yeah. So then we talked about Cortex and Thanos because they seem kind of similar. What differentiates the two? I guess what's the same and what's different between Cortex and Thanos?
Well, Cortex and Thanos share a lot. There's even a maintainer that is a Thanos and Cortex maintainer, right? So we share even people as well. So in the code, Cortex reuses a lot of the Thanos code. There is different approaches. There are different things that have been done over the years. We're getting closer and closer over the years. Nowadays, one could say that Cortex is really special for multi-tenancy, right?
Yeah.
It's really good for that.
It shines in a multi-tenant use case. And you also said it's good for scaling. With Thanos, you might have to manually configure when you want to scale instances. And then Thanos is good when you already have lots of instances of Prometheus running and you want to just put a solution on top of your existing Prometheus. And then finally, so we already talked about the client view because it's important to say from a client perspective, all the distributed nature of the data, whether it's long-term or short-term storage, all of that's invisible to the client. They just submit a query and that's that. But the operations view, will you say a little bit about that if you're not someone operating?
Yeah, as an operator of Cortex, you do have to know all of this, right? So you want to have dashboards and alerts, and you want to have control over everything that we talked about, right? Limits, everything.
Awesome. So if I'm watching this video, I'm interested in Cortex, I have questions, where should I go to ask questions for the community?
I think the best place and the most where we have all the community asking questions all the time and people getting answered is the CNCF Slack channel for Cortex. That would be #Cortex.
Well, thank you so much for sharing your time and your expertise with us today. I appreciate you.
Thank you.
Thank you. Thanks everyone for watching. Goodbye.